As you know that our main topic or main chapter is kinematic. With reference to kinematics, we have already discussed the distance, displacement, speed, velocity, etc., vectors and scalars. Precisely, we have discussed vectors and scalars, but in detail, we have to discuss vectors later, inshallah. Now, the topic which I am going to discuss with you is the uniform acceleration. As I told you, that if the velocity of a body constantly changes in a unit time, the body accelerates uniformly. It means acceleration does not change with time. One very important thing which you must remember, that what are the things which may cause a body to accelerate? Why there is acceleration? There may be two causes of acceleration. Okay, well, why there is acceleration? The acceleration may be due to the change in speed or change in direction. Acceleration may be due to acceleration may be due to number one, change in speed or change in direction. These are the two major factors which affect the acceleration. If the body is slowing down or its speed is increasing, then obviously there will be acceleration. And if the direction of the body is changing, even then there will be acceleration. As you know that velocity is a vector quantity. Velocity is displacement over time. So if the velocity is changing, then it means the acceleration is also there. I suggest students that you must use uh, laptop daily. Whenever I take class, I tell you that you must use laptops. So on the laptop you can see the screen clearly, inshallah. Very good. Well, uh, actually, well, Hamza. Okay, Hiba Atif is saying it is clear even on mobile. Okay, Hiba Atif, if it is clear on mobile, it's okay. Actually, if someone is facing any problem, blur problem, then I think so his or her network may be causing any problem. As you know that, now let us come to the point. Okay, well, come to the point because I have also, okay, Mehreen and other students who are saying that they can see clearly. So without wasting time, let us complete this topic. Acceleration may be due to change in speed or change in velocity. Okay. Well, those change in speed and change in direction may also cause the velocity to change. Okay. So when the velocity is changing, it means there is acceleration. As I told you, that rate of change of velocity is called acceleration. Now, very important thing which I'm going to discuss is uniform acceleration, which I just want to tell you that what is uniform acceleration. As I gave you the definition, that if the velocity of a body constantly changes in a unit time, the body accelerates uniformly. Constantly changes in a unit time. It means the change in velocity is equal in equal intervals of time, then the acceleration will be uniform. Concentrate to my words that if the velocity is changing uniformly in equal intervals of time, or you can say that equal changes in velocity are occurring in equal intervals of time, then the acceleration will be uniform. Equal changes in velocity in equal intervals of time, then its acceleration will be uniform. And as for the non-uniform acceleration is concerned, if the velocity of the body does not change constantly in a unit time. For each unit time, the change in velocity is not uniform. For each interval of time, when the change in velocity is not uniform, then it is called non-uniform acceleration. Let us have an example. For example, uh, I am drawing time axis, time and velocity. As I told you that what is acceleration? For example, during the 0 second, when there is no time passed, the change in velocity, the velocity was 20 meter per second. After 1 second, the velocity has become 25 meters per second. Then it is 30 meters per second. Okay, so change in velocity is occurring. Now, if I am taking the third second, now it is 35 meter per second. You can have this example. Okay, so with the help of this table, please find out the acceleration. Let me please, guys, let me take remove the students who are not the students of our class. Okay, like there is a student who is disturbing constantly. Actually, I had to remove that. Okay, so actually I told you students that you must come with your correct names and with your sections also. So I hope that you understand this, that you must come with the sections. Those who are not coming with the sections, please, I have left the option open to write their section, but don't do it now. Whenever you will join again, then at that point you can change the section. Okay, well, actually there was a student like below Rani who was disturbing again and again. That is why I had to re remove him or her. Okay, well, guys, from here, if I'm going to find out the acceleration, as you know, that acceleration is change in velocity, change in velocity over time. As I told you that what is acceleration? Change in velocity. So from 20 to 25, 25 minus 20 over. The time interval is 1 second. 1 minus 0 is 1 second. 5 over 1. It means your acceleration is 5 meter per second square. Now, during the second interval, This I can name as, this is the first acceleration. I can say that A1 is the first acceleration which I calculated during these two intervals. Now for these two intervals, if I am going to check the acceleration, A2, say I am naming it myself like A2, 30 minus 25, final velocity minus initial velocity. Final velocity minus initial velocity. Initially the velocity was 20, but then it became 25. So from the final velocity, I subtracted the initial velocity. So I got the acceleration like this. Again, I am taking this interval from first to till 2 second. Okay, so 30 minus 25 over 2 minus 1. Again, you can see that it is 5 over 1, which is equal to 5 meter per second square. Okay. In the same way, if I am going to take the third section, this 35 minus 30 over 3 minus 2 is equal to 5 over 1 is equal to 5 meter per second square. Now here in this example, you may observe that for each unit time, the same changes in velocities are occurring. So you can see that the acceleration is uniform acceleration. Yes, it is a uniform acceleration. Now let us consider another example in which I am using another table, time, and this is velocity, 0, 1, 2, 3. Say initially the velocity was 20 meter per second. Then it became 25 meter per second. Now it became 40 meter per second. Then it becomes 15 meter per second. Okay. Now please concentrate to this example. After concentrating on this example, you may also understand that previous example also. Concentrate here instead of writing the questions again and again. Please concentrate. Well, now look here again. I am going to find out the first A1 acceleration for this non-uniform acceleration. Change in velocity, the initial velocity I am taking 20, the final velocity I am taking is 25. So from the final velocity, you have to subtract the initial velocity and the time interval 0 and 1. 1 minus 0. You can see that here is 5 meter per second square. Now another acceleration for the second interval of time, A2, final velocity minus initial for this interval of velocity or this interval of time, 40 minus 25, 40 minus 25 over 2 minus 1 is 1. So here it is 15 over 1 is equal to 15 meter per second square. In the same way, if I am checking for the third interval of time, you can see that the final velocity is 15 and the initial, okay, instead of taking this, I am taking it 65. Well, instead of taking 15, I am taking it 65, please. 65 minus 40 over the change in velocity 3 minus 2. A change in time is 3 minus 2, again 1. So 65 minus 40 is 25. 25 over 1 is equal to 25 meter per second square. Now here you can see that for each equal intervals of time, here the change in velocity is different. For each 1 second, you can see during the 0 till 1 second, the change in velocity was 5. From 1 till 2 second, the change in velocity was 15. From 2 till 3 second, the change in velocity was 25. So for each 1 second, for each unit time, here the change in velocity is different. So here we can see that the acceleration is not uniform from 0 till 3. But here in this case, the acceleration was uniform from 0 till 3. Initially it was 5, and for each intervals of time, you can see that acceleration is constant. So this is an example of simple example of uniform and non-uniform acceleration. This I'm naming as uniform acceleration, uniform acceleration, and here it is non-uniform acceleration, non-uniform acceleration. Okay, well, let me see that what question many students are writing. Actually, I told students that please concentrate to my lecture, but I'm sorry to say that they are not concentrating to my lecture. Instead, they are writing the question. If they would have listened to me, that I think so that you could understand fully. Now, let me see. One student is writing that I am confused for something that I want to understand by example. Can I give an example table? No, I understand the example that is not uniform, but I have a different thing. I want to discuss what would happen if there was acceleration and deceleration in a table. I'll tell you, bache, pehle, first of all, I will have to tell you that what is a deceleration. I have not defined a deceleration. So please, later on, I'll tell you. So that is why don't get yourself confused. You have given me an example like 0 is equal to 20%, 1 is equal to 30. No, this actually whenever, whatever you are writing now, actually you are confusing two things. So that what do we classify it as? Okay, sir, but what is the use of knowing if it's uniform or not uniform? Can you show the definition page, please? It can be used to predict, but it is there any other use of knowing, sir? I have listened to everything. Now I want to ask that why did you took it 65 instead of 15? Okay, I was concentrating. I have understood completely, sir. I have listened everything. Okay. Now there is a student, who is saying that initially I took 15, that but later on I changed it to 65. So actually I had not given you the idea of deceleration. That is why I just wanted to give the definition of uniform acceleration. That is why here I got increasing velocity. That is why I took 65 instead of 15. Okay. Now, first of all, because before telling you a table with increasing or decreasing velocity, let me tell you that what is deceleration, because I have to move stepwise. So you people are in a habit of moving directly. Uh, Actually, I am not in that habit. I just want to explain one by one. Deceleration. The word is deceleration. Deceleration. Please look at the definition of the deceleration. If the velocity of the body decreases in a unit time, body decelerates. Okay. Whenever the velocity is decreasing, it means the body is decelerating. Deceleration is also called retardation or the negative acceleration. Listen to my very to me very carefully that negative acceleration is called deceleration. First of all, I would like to give you an example, and then I'll make a table in which sometime I'll show you increasing velocities or decreasing velocity. Then I can show you that what is the difference between acceleration and deceleration. Well, so let us do this. I am talking about deceleration or retardation. For example, initial velocity, I am taking as initial velocity, say u is initial velocity. I am naming u as initial velocity. Say it is 25 meter per second. And the final velocity v, say it is 10 meters per second. And the time interval during which this velocity change occurred, say it took 2 seconds to change the velocity. What I told you, that suppose the initial velocity is 25 meter per second. Final velocity is 10 meter per second. And the time interval during which this change occurred is 2 seconds. Okay. Now I have to find out the acceleration. Remember this very important thing, that whenever you are going to find acceleration or deceleration, both the things are calculated with the same formula. The formula is the same. A is equal to final minus initial. In alphabetical order, U comes first and V comes later. So final minus initial, U minus V minus U over the time. Change in time is 2 seconds. So apply the values. 10 minus 25 over 2. This gives you minus 15 over 2, and this is equal to minus 7.5 meter per second square. So here you can see I got a negative sign with my answer. This negative sign is showing that this is deceleration, that the body is decelerating. Although if we are writing the same symbol, A, acceleration is equal to minus 7.5 meter per second square. So from this negative sign, you will conclude that the body is decelerating, or you can say that the velocity of the body is decreasing. Okay. Well, so if you are writing the word deceleration, Deceleration, then you will have to write 7.5 meter per second square. Okay. If you are writing acceleration, then you will have to mention this negative sign. But if you are writing deceleration, there is no need to mention the negative sign, because deceleration word itself suggesting you that the velocity is decreasing. Okay. So basically deceleration is the negative acceleration. Okay. In the same way, uniform deceleration mean uniformly decreasing the velocity, and non-uniform deceleration mean non-uniformly decreasing velocity. Okay. Well, again, let me see the questions of the students. Okay, some student is saying that, sir, previously you used the same formula, but U minus V. Bache, you were not understanding that in the previous example. Also, let me put that page before you. There is a decrease in velocity. Okay, let okay. I am placing this page again before you. Look here. Here also, this was the final velocity. This was the initial velocity. If I'm taking this interval, for this interval, this is the final velocity and this is the initial velocity. If I am considering this interval, for this interval, this is the final and this is the initial. So you can see that final minus initial. In the same way, if I am considering this interval, say, so this is the final, this is the initial. Always I have to subtract the final minus initial. There is nothing like initial minus final. So remember this very important thing. Whenever you are finding out the acceleration, the final velocity minus the initial velocity. Okay. Well, guys, now let me give you another example and another thing which I just want to tell you. Suppose I have the time and this is the velocity. I am writing the velocity instead of writing initial or the final velocity. We have almost 10 minutes to go. Okay. Well, next topic, inshallah, we'll be doing the distance time graph and the velocity time graph. That is a very important topic. So please be prepared for that, because please don't miss that topic. Please join as soon as possible. Whenever the time starts, you must join the class. Those who come late, they miss Okay, well, let us see. For 0 second, the velocity was 20 meter per second. After 1 second, the velocity has become 30 meter per second. 2 second, the velocity has become, say, 35 meter per second. Okay. Say after 4th second, I'm skipping the 3rd second. After 4th second, the velocity has become 10 meter per second. Now here I have given you the combination of increasing and decreasing. Well, guys, sorry, there was an interruption. There was a call from the administration. That is why I had to take that call. That was very important call. You know that whenever there's a call from the administration, we have to take that call. Okay. Well, guys, here I have shown you a table, very precise table. Here you can see from 0 to 2, the velocity is increasing. From 2 to 4, the velocity is decreasing. For example, if if I am going to find out for these intervals of time, acceleration 0 till 1 or 0 till 2, I am directly taking 0 to 2. A letter I am introducing you, delta V. This letter is called delta. Delta shows change over delta t. This notation is called delta. Delta. Okay. So this letter is used to change to show you the change. Change in velocity divided by change in time. Change in velocity, say I am taking this interval from 0 to 2. Change in velocity, final velocity minus initial velocity. Say this is the final velocity for this interval of time, and this is the initial velocity. Final minus initial over time interval. This is 2 minus 0. Apply the value. The final velocity is 35 and the initial velocity is 20 over 2. So it will be 15 meter per second square. Now let us consider the second interval like this here again. Now if I am considering this interval, now I'll consider this as u and this as v. So now here acceleration, the final velocity will become this and the initial velocity will become this because I am considering this interval. Okay. Sorry. Thank you so much, Bache. Thank you, whoever told me 15 divided by 2. I actually haste makes waste now because I have very little time to conclude this. That is why in hastily I committed this mistake. So please be sure about it. Okay. Now here the final velocity is 10 and this is 35. 10 minus 35 over change in time is 4 minus 2. This is again minus 25 over 2 meter per second square. You can write it in decimal, or likewise we can also write in decimal like 7.5 meter per second square, or this can also be written like 12.5 meter per second square. So this is an example of mixed table. So I hope that you have understood the concept of velocity and acceleration and uniform acceleration. And next topic will be very important topic, Bache. That will be related to uh, that will be related to speed time graph and velocity time graph. As you know that there are different concepts regarding the speed time graph and the velocity time graph. We'll draw those graphs, inshallah. And after drawing those, after sketching the graphs, basically we'll learn that how to sketch a speed time graph and the velocity time graph. And from those graphs, we'll find out the acceleration also. Okay, so we'll also find out the acceleration with the help of those speed time and the velocity time graphs. So you will please today's video will also be uploaded, and I'll also upload the related videos about speed time graph and the velocity time graph. And I'll suggest you that please do watch these videos, which will be very helpful videos to understand. Now let me see that what the questions during the last. Can you show the definition page? Okay, I'll show. Sir, what is the meaning of triangle? Okay, actually the triangle which I used, first of all I would like to tell you again that this triangle which I used, this is called delta. 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 And delta, basically this shows, yes, delta, this shows change. This shows whenever I'm using this delta v or delta t, it means change in velocity over change in time. Okay, and you have to learn the definitions of velocity, time, acceleration, uniform acceleration, etc., because sometimes the definition may be asked. So whenever the definition is asked, you must not write definition yourself. You have to learn the definitions because exact definition must be written. So here I have given you the definition page again. Uniform deceleration: if the velocity of the body constantly decreases in a unit time, the body decelerates uniformly. Non-uniform deceleration: if the velocity of the body does not changes constantly in a unit time, body decelerates non-uniformly. Okay, so these are the basic definitions, and if you will watch this video again, you can be able to see this page again, and you can revise this lecture, because it is very important to revise the whatever you have done today. And for the revision purposes, if you will listen these videos again, inshallah it will be very helpful. Okay, now we have almost 1 minute. So during this going 1 minute, let me give you another example, because I don't want to waste even a single minute of time. So please don't leave the class until I am explaining something. So in between, if whatever will be remaining, I'll inshallah tell you again during the next class. Okay, here I am using a piece of paper on which I am going to draw the distance time graph. Distance time graph. One very important thing, whether it is a distance time graph or it is displacement time graph. Listen to my words very carefully. The distance time graph or displacement time graph. If we are talking about distance time graph or displacement time graph. Displacement time graph. Both graphs are drawn in the same way. Remember this, whether it is distance time graph or it is displacement time graph, both the graphs are drawn in the same way. Because you know that when in a graph, we are not showing the direction of the body, because the direction of the body cannot be shown with the help of the graph. Well, so if it is written distance time graph, then distance will come on the y-axis and time will come on the x-axis. Like here, if I have written both the axes, this is x-axis, this is